Hello everyone. In this section we are going to discuss about the compound interest and what is meant by compound interest. Compound interest is the interest on savings calculated on both the initial principal and the accumulated interest from the previous period. And this is the simple Python program to calculate the compound interest on a given principal amount, in which the first line is used to obtain the principal amount from the user and store that value on a variable n, and the second line is used to obtain rate of interest and store that value on variable r, and the third line is used to obtain the number of years the user plans to invest on a variable y, and the line number 5 is the standard equation for calculating the compound interest. This line containing two parts. The second part is equivalent to find the compound interest in each and every year, and the first part is equivalent to adding the principal amount with the calculated compound interest. This line 5 has to be executed number of times equivalent to the number of years that the user is entered. And finally, we are printing the total amount on the screen and exit from program execution. And the code segments show the corresponding low-level instruction. And the first line is used to indicate that we have 5 global variables, namely n, r, y, I and temp. And the second line is equivalent to the first line in your Python program, which is used to obtain input from the user, that is the principal amount from the user, and store that value on the variable n. And this line is equivalent to the second line in your Python program, used to obtain the rate of interest from the user and store that value on a variable r. And the fourth line is obviously equivalent to the third line in your Python program, used to store the number of year value. And the fifth line is used to assign our global variable temp with the 100, which will be used in later for doing division operation. And on the sixth line, we are initializing the loop control variable I with the value 1. So this loop control variable might be useful for the for statement. Then on the seventh line, we are loading the number of year to the R0 registers inside your CPU. And line number 8 to line number 22 is equivalent for your for code segment, that is this entire section. Inside the for loop, first what we do, first the increment value or the loop control value is loaded into the R1 register, here R1 register, and we are checking the condition whether R1 value is lesser than or equal to R0. If the condition is false, then our control goes to the L1 labeled segment. In the L1 labeled segment is on the 23rd line. In that line, we are just printing the principal amount and exit the program. Otherwise, if the condition is true, then our control goes to the line number 12, in which the principal amount is loaded to R2 and the rate of interest is loaded to R3, and we are performing a multiplication between the values stored in R2 and R3, that is line number 40 is equivalent to n into R, and storing that multiplied value back to R2 register. Now we are loading the temp value to R4 register, so your temp containing value 100, and we are performing a division operation on the value stored in R2 and R4. So your R2 storing n into R value and R4 storing 100, and the result is stored back to R2 register itself. Then we are loading the principal amount to the R5 register. So your R5 currently containing this n value, and we are adding this n value to this value. So this value will be stored in which register? R2 register. So we are adding the values in R5 with the R2, and the added value is stored back to variable n. Then we are incrementing the R1 value. So your R1 containing the loop control variable. Then storing back that result to I. And if the condition is still true, then our control goes to the L0. So this loop will be executed till the loop control variable I is lesser than or equal to the number of year. When the condition became false, your program control goes to the line number 23rd and print the principal amount with the compound interest and exit from the program execution. Now we can run the program to visualize the flow of control by clicking the start button. The first line causes 5 global variables to be created in your data segment, and the next line prompt the user to enter the principal amount. Here I am entering 1000 as the principal amount, and the rate of interest will be 8% per annum, and the user plan to invest the amount for 2 years. Then the fifth line causes your temporary variable to be assigned with the value 100. Then the sixth line assign the loop control variable with value 1. This is the initialization. Then on the seventh line, you are loading the number of year to register R0. So now your R0 containing number of year that the user plan to invest. And line number 8 indicate the start of the for loop. On line number 4, your loop control value is stored into R1. Then you are going to check whether the value in R1 is lesser than R0 by using the LTE statement, that is lesser than or equal to statement, and the condition found to be true. So since the condition is true, our control goes to line number 12. On line number 12, we are loading the principal amount to the R2 register and the rate of interest to the R3 register. Then you are performing a multiplication operation. So that operation is equivalent to n into r. So the result 8000 is stored back to R2. Then we are loading R4 with the temp value, that is 100. Then we are performing the division operation and the result is stored back to R2. So this statement is equivalent to the entire Python code, this entire Python section. Then you are loading the n value to R5 and you are adding that R5 with the R2. So your R2 containing this interest and R5 containing the principal amount. So the sum 1080 is stored back to R5 itself. Then we are storing back this R5 value to the n variable. So now our principal amount after 1 year is 1080. Now we just increment the R1 value by 1. So currently R1 value is 2. This 2 is stored back to our loop control variable. And since our condition is true, we are going back to L0 label. Again we are loading I value. Now the I value is 2, that is loaded to R1. And we are checking whether value in R1 is lesser than or equal to R0. So the condition is found to be true. So our control goes back to line number 12, in which we are loading the current principal amount, that is 1080 to R2 register, and load the rate of interest to R3. Then we are performing the multiplication operation. Then we are loading the temp value to R4. Then we are performing a division operation. And 86.4 is the compound interest for the second year, and your principal amount was 1080, and you are loading the principal amount to the R5 register and perform the addition operation. As a result, you might get 1166.4, and you are storing that result back to your principal amount variable n, and you again increment the R1 value. Now the R1 value is 3. This value is stored back to the loop control variable 3. Since this condition was true, our control goes to the line number 8. You are loading the increment value to the R1 register, and the next line you are comparing whether R1 is lesser than or equal to R0. The condition is false. So our control goes to the label named L1, that is on 23rd line, in which you are printing the amount on the screen. That is, you will get 1166.4 rupees after 2 years, and you are exiting from the program execution.